Hello and welcome to Lucid Mind. This is Majid and today I'll be solving Chemistry A-Levels Multiple Choice Paper 12 from October-November 2020. You can go to any particular question by following timestamps given in the video description. Let's start.
Question 1. What is the average oxidation number of sulfur in each compound? We have calcium hydrogen sulfite CaHSO3 and we have Na2S2O3. Let's find out the oxidation state of sulfur. In the first compound we have 1 calcium atom, 2 hydrogen atoms, 2 sulfur atoms, 6 oxygens, and overall charge is 0. Similarly, for this compound we have 2 sodium atoms, 2 sulfur atoms, 3 oxygen atoms, and overall charge is 0. Calcium is in second group, so the charge on one calcium atom will be plus 2. Similarly, the charge on hydrogen is plus 1, so for 2 hydrogen it will be plus 2. We have to find the charge on sulfur. 1 oxygen is negative 2, so 6 oxygen will be negative 12. So 2 sulfur minus 12 plus 4 will be equal to minus 8 equals 0. So 2 sulfur is equal to plus 8. The oxidation state on 1 sulfur will be plus 4. So it could be either A or B. Moving to the second one, we have 2 sodium. As sodium is plus 1, so it will become plus 2 for 2 sodium. 2 sulfur. For 1 oxygen it is negative 2, so for 3 oxygen it will be negative 6 equals 0. 2 sulfur negative 6 plus 2 equals negative 4. 2 sulfur equals plus 4 and 1 sulfur will be equal to plus 2. Therefore, answer is A. Question 2. An O of manganese contains 4% by mass of MnO2 and no other manganese compound. Which mass of manganese would be obtained from 1 ton of this O? They have given the percentage of MnO2 in the O of manganese, so we can find the ratio. As MnO2 is 4%, so we can write 4 for MnO2 and 100 for O. As in the question, we have 1 ton of O, which is 1000 kilograms. So if we take this percentage as kilograms, we can write 1000 kg for O and X for MnO2. Let's find the amount of MnO2 in 1000 kg of O. We can cross multiply. X will be equal to 4000 divided by 100, which equals 40 kilograms. So we have 40 kilograms of MnO2 in 1000 kilograms of O. In the second step, we can find the mass of manganese in MnO2. The atomic mass of manganese is 54.9 and of 1 oxygen is 16, so for 2 oxygen it will be equals to 32. The molecular mass is 86.9 for MnO2. Similarly, for manganese, atomic mass is 54.9. Now we can find the ratio between two, Mn ratio MnO2. So for 86.9 MnO2 we have 54.9 manganese. So for 40 kilograms of manganese dioxide that we just obtained, we would have X kilograms of manganese. By cross multiplying we can find the value. It is 25.27 kilograms of manganese in 1000 1000 kilograms of O. Therefore, answer is A. Question 3. Which atomic orbitals are occupied in an atom of phosphorus? The atomic number of phosphorus is 15. So we can write the electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p3. Option A, we have 1p, 2s2p. As we can see, there is no 1p involved, so A is incorrect. In B, we have 2s, 2p, 2d. 2d is incorrect. In C, we have 2s, 2p and 3s. 2s, 2p and 3s are present, so C could be correct. In D, we have 2p, 3s and 3d. As 3d is not involved, so D is incorrect. The answer is therefore C. Question 4. The structure of compound A is shown. This is compound A. Some of the carbon atoms in compound A have a tetrahedral arrangement of bonds. Some of the carbon atoms in compound A have a trigonal planar arrangement of bonds. How many carbon atoms are there of each type? In tetrahedral arrangement, what happens that one carbon makes 4 single covalent bonds with 4 other carbon atoms, and the bond angle is 109.5. While in trigonal planar, what happens that we take double bond as a single bond, so therefore in total there are 3 bonds and the bond angle will be equal to 120 degrees. Let's find out which carbon is making 4 single covalent bonds. So we have CH3. The carbon is bonded with 3 hydrogen atoms and 1 carbon. Second is also CH3. This is also making 4 bonds. This carbon is making 4 single bonds, 2 CH3 and 2 with the ring. Again, we have 2 hydrogen atoms on this carbon, so this is also making 4 bonds. Similarly for this carbon is making double bond, this is making double covalent bond. These two are also making double covalent bond. This is making double covalent, but this is making 4 single covalent bonds. Similarly, we have this CH3 and this carbon is also making 4 covalent bonds. 2 with hydrogen atoms, 1 with OH and 1 with this carbon. So in total we have 9 carbons which are making single covalent bonds, and the arrangement will be tetrahedral. So option C and option D could be correct. Now let's find the carbon atoms making 3 bonds. We have 1 hydrogen with this carbon. So this carbon is making 1 double covalent bond and 2 single bonds. So the arrangement will be trigonal planar. Similarly for this carbon, again we have 1 double covalent and 2 single bonds. This carbon is making 1 single bond with hydrogen, a double bond with carbon and a single bond with this carbon. So this is also trigonal planar. Similarly this is also trigonal planar. This one and these. So in total we have 8 carbon atoms that are making at least 1 double bond and 2 single covalent bonds. The answer is therefore D. Question number 5. A white powder is known to be a mixture of magnesium oxide and aluminum oxide. 100 cm³ of 2 mole per decimeter³ sodium hydroxide is just enough to dissolve the aluminum oxide in X grams of mixture. The reaction is shown. This is the dissolution of aluminum oxide in alkaline solution. 800 cm³ of 2 mole per decimeter³ HCl is just enough to dissolve all of the oxide in X grams of the mixture. The reaction is shown. First reaction is the dissolution of alumina in acid. Second is the dissolution of magnesium oxide in HCl. How many moles of each oxide are present in X grams of the mixture? In the question we have white powder of MgO and Al2O3. We can find the number of moles of sodium hydroxide from the concentration and volume. So N is equal to concentration into volume in decimeter cube. Concentration is 2 mole per decimeter cube and volume is 100 centimeter cube, which could be changed into decimeter cube by dividing by 1000. So number of moles of sodium hydroxide will be equal to 0.2 mole. Similarly, we can find the number of moles of HCl. N equals concentration in mole per decimeter cube into volume in decimeter cube. So it will be 2 into 800 divided by 1000. And number of moles of HCl are 1.6 moles. In the statement they say that sodium hydroxide dissolves aluminum oxide. So we can take the ratio between aluminum oxide and sodium hydroxide. According to the balanced equation, 2 moles of sodium hydroxide dissolve 1 mole of aluminum oxide. So we can write 2:1. As we have 0.2 moles of sodium hydroxide given, so 0.2 moles of sodium hydroxide will dissolve X moles of aluminum oxide. By cross multiplying we can get the value of X. X equals 0.2 divided by 2, which equals to 0.1 mole of aluminum oxide. So we can say that 0.1 mole of aluminum oxide are present in the mixture. So either it is C or D. Now moving towards second part, we have HCl, which dissolves all of the oxide, whether it is aluminum oxide or magnesium oxide, in X grams of the mixture. Now let's find the number of moles of magnesium oxide that will be present in the mixture. According to balanced equation, 1 mole of aluminum oxide is dissolved by 6 moles of HCl. So we can write the ratio between aluminum oxide and HCl. It is 6:1. As total number of moles of aluminum oxide present in the mixture were 0.1 moles, so we can write 0.1. So X moles of HCl will be required to dissolve 0.1 moles of aluminum oxide. So X equals to 0.6 moles of HCl. As total number of moles of HCl were 1.6 moles, out of which 0.6 moles will be required to dissolve aluminum oxide, so the remaining will be able to dissolve magnesium oxide. Now finding the remaining moles of HCl, we have 1.6 moles minus 0.6 moles, which equals 1 moles of HCl. According to the balanced equation, 2 moles of HCl dissolves 1 mole of magnesium oxide, so we can write H plus ratio MgO 2:1 from balanced equation. So as we have 1 mole of HCl left, so 1 mole of HCl will dissolve X moles of magnesium oxide. So the number of moles of magnesium oxide dissolved by 1 mole of HCl will be 0.5 moles MgO. The correct answer is therefore D. Question 6. A graph of PV against temperature is shown for a fixed mass of gas. P is pressure, V is volume and T is temperature in Kelvin. Which gas gives this graph over the widest range of temperatures and pressures? This graph shows the relation between pressure, volume and temperature. So as the temperature is increased, the pressure of gas also increases and the volume of gas also increase. So pressure into volume will also increase, so therefore graph is straight line. At higher temperatures, what happens that the kinetic energy of the molecule increases. So therefore molecules move further apart, so temperature is directly proportional to volume. Similarly, for a fixed mass, temperature is directly proportional to the pressure as more kinetic energy will be coming to the molecules, so molecules will exert more pressure on the walls of container. So we can say that temperature is directly proportional to the product of pressure and volume. At higher temperatures, this will be true for all of the gases. In the options, we have hydrogen, which is a small molecule, HCl gas, which has partial charges, HF having hydrogen bonding, and oxygen molecule, which is larger than hydrogen. At higher pressures, what happens that the molecules will come close to each other and forces of attraction will develop. So as there are already partial charges on hydrogen chloride and HF, so the intermolecular forces will be the strongest among these two. So the volume of these gases will decrease more than expected because of the intermolecular forces of attraction. With oxygen, we can see that only dipole-induced dipole forces will be present. Which will result in decrease in volume. While in hydrogen, we can see that the smaller size is present, so therefore the force of attraction will be minimum as compared to other gases. So hydrogen gas is more close to ideal gas. So therefore it is hydrogen which will give this graph over a wide range of temperatures as well as pressure. The answer is therefore A. Question number 7. A weather balloon is filled with 12 kilograms helium gas. The weather balloon reaches a height of 20 km. The pressure inside the balloon is 6000 pascals and the temperature is 216 Kelvin. What is the volume of the weather balloon at this height? Correct to 3 significant figures. We can find the volume by using ideal gas equation. PV is equal to nRT, where P is the pressure in pascals, V is the volume in meter cube, N is the number of moles, R is ideal gas constant, T is the temperature in Kelvin. So volume will be equal to number of moles into R into T divided by pressure. Let's find number of moles of helium. We have 12 kilograms, as moles is equal to mass divided by molecular mass. So 12,000 grams divided by the atomic mass of helium, which is 4. So it equals to 3000 moles of helium. Now putting the values in volume, we have 3000 moles into ideal gas constant, which is 8.31, into temperature in Kelvin, which is 216, divided by the pressure 6000 pascals. So volume is equal to 897.48 meter cube. Now converting this value into decimeter cube, we can multiply by 1000. So it comes equal to 897,480 decimeter cube. As first 3 digits are significant, so therefore answer is C. Question number 8. Which pair of enthalpy changes will always share the same sign? That is, both are always exothermic or both are always endothermic. A. Enthalpy change of atomization. Now what happens in atomization is that we break down a molecule into its atoms. For example, we have hydrogen. We can break hydrogen molecule into the atoms of hydrogen. So the breaking of bonds requires energy, so therefore enthalpy change of atomization is endothermic in nature. Enthalpy change of neutralization is when acid reacts with alkali to form salt and water, and this reaction is always exothermic. So A is incorrect. B. Enthalpy change of atomization. Again, this is endothermic. And enthalpy change of solution. Now what happens in solution, that a solute is dissolved in enough volume of solvent to make up a solution. Now the enthalpy of solution is dependent on the type of solute. So it could be either endothermic or exothermic in nature. C. Enthalpy change of combustion. In combustion, what happens that something burns in the presence of oxygen and it is exothermic in nature as energy is released. Enthalpy change of hydration is when gaseous ion converts into aqueous ion. Now we can see that the gaseous atomic ion has very high energy as compared to the aqueous ion. So the energy is released in enthalpy change of hydration. So it is also exothermic in nature. So C could be correct option. In D we have enthalpy change of solution, which is dependent on the type of solute. So it could be exo or endo. And enthalpy change of hydration, which is exothermic in nature. So in C we can see that the enthalpy changes are always the same. So therefore answer is C. Question number 9. Chlorine dioxide ClO2 reacts with sodium hydroxide in the reaction shown. We have 2 moles of ClO2 that reacts with 2 moles of sodium hydroxide. Which statement correctly describes this redox reaction? We can find the correct option by finding the oxidation states of chlorine. So we have ClO2 and the overall charge is 0. We have ClO2 on the product side and the charge is -1. We have ClO3 on the product side and the charge is also -1. We can find the oxidation state of chlorine atoms in all these three. The oxidation state of oxygen is -2, so for 2 oxygen we would have -4, so therefore chlorine is equal to +4. So it is +4. In the second one, again -4 for 2 oxygen atoms, and it will be equal to +3. So it is +3 in one of the product. In second product there are 3 oxygen, so it is -6. So chlorine equals to +5. The oxidation state of oxygen is -2 in all of the compounds. Option A. Chlorine atoms are oxidized and oxygen atoms are reduced. As there is no change in the oxidation state of oxygen, so this is wrong. B. Chlorine atoms are reduced and oxygen atoms are oxidized. Again, this is incorrect because there is no change in oxidation state of oxygen. C. Some chlorine atoms are oxidized and some chlorine atoms are reduced. We can see that chlorine atom goes from +4 to +5, which is oxidation. It also moves from +4 to +3, which is reduction. So this is correct. D. Some oxygen atoms are oxidized, oxygen is not oxidized, and some oxygen atoms are reduced. Correct option is therefore C. Question 10. Sulfur dioxide and oxygen react to form sulfur trioxide. The reaction is reversible. We have 2 moles of sulfur dioxide that reacts with 1 mole of oxygen to form 2 mole of sulfur trioxide. Kp for this reaction is given per pascals. Temperature is 700 degrees centigrade. The reaction is allowed to reach equilibrium at 700 degrees centigrade. The partial pressure of oxygen is 375 kilopascals and the partial pressure of sulfur trioxide is 20.3 kilopascals. What is the partial pressure of SO2 gas? We can start with the formula of partial pressure. Kp is equal to the pressure of product, which is sulfur trioxide, raised to the power is number of moles. We have 2 moles of SO3 divided by the partial pressure of each of the reactants. So we have SO2 raised to the power is number of moles into partial pressure of oxygen raised to power 1. As we have to find the partial pressure of SO2, so we can write Kp into pressure of SO2 square equals pressure of SO3 square divided by pressure of oxygen. Putting the values, the partial pressure of SO3 is 20.3 kilopascals divided by the pressure of oxygen is 375 kilopascals. So the value is 1.0989 kilopascals. As the value of Kp is given in per pascals, so we can convert our kilopascals into pascals by multiplying with 1000. So it will be Kp dot PSO2 square equals 1098.9 pascals. Pressure of SO2 square will be equal to 1098.9 pascals divided by 2.96 exponential minus 9 per pascals, which is equal to 37125 exponential 7 pascal square. We can take under root on both sides. So pressure of SO2 is equal to 609302 pascals or 609 kilopascals. The answer is therefore B. Question number 11. Ammonia is made by Haber process. The reactants are nitrogen and hydrogen. This is the balanced equation. Enthalpy change is negative. What will increase the rate of forward reaction? A. Adding argon. Argon is an inert gas to the mixture but keeping the total volume constant. Adding argon will increase the pressure of the system, but we can see that the partial pressure of nitrogen, partial pressure of hydrogen and partial pressure of ammonia won't be affected, so therefore there will be no effect on the rate of forward reaction. B. Decreasing the temperature. As the reaction is exothermic in nature, so decreasing the temperature will lower the rate of reaction. This is because less collisions will occur. C. Increasing the total pressure by reducing the total volume at constant temperature. When pressure is increased, the molecules will come close together and the rate of reaction will also increase. Now we can see that we have more number of moles of the reactants, so therefore rate of reaction will be more in the forward direction. So C is correct. D. Removing ammonia as it is made but keeping the total volume of the mixture the same. As the total volume is same, so therefore the pressure will also be the same, and removing ammonia will result in the position of equilibrium to move in the forward direction. There will be no effect on the rate of forward direction. So therefore C is the correct option. Question number 12. Element X in period 3 has the following properties. Its oxide has a giant structure. It forms a covalent bonds with chlorine. Its oxide will neutralize HCl aqueous. What is element X? They have given 4 elements: magnesium, aluminum, silicon and phosphorus. Now the oxides will be MgO, Al2O3, SiO2 and P4O10. Magnesium oxide is an ionic compound, so it has a giant ionic structure. Aluminum oxide also has a giant structure. Silicon dioxide is a giant covalent compound, while phosphorus oxide is a simple molecular one. Second option, it forms covalent bonds with chlorine. As magnesium is a metal, so it forms ionic bond, so it is incorrect. Aluminum can form covalent bond, so it could be aluminum chloride. Similarly, silicon tetrachloride also makes a covalent bond. Third option, its oxide will neutralize HCl aqueous. As we know that the oxide of aluminum is amphoteric in nature, so it can neutralize acid as well as alkali. Second is the oxide of silicon. Silicon dioxide is acidic in nature, so therefore it cannot neutralize HCl. So the correct option is B, aluminum. Question 13. Which row could refer to barium metal and barium hydroxide? First option is the color seen when the metal is burnt in oxygen. When barium metal burns in the presence of oxygen, the color shown is green flame. So it could be A or B. Second option is the pH of saturated solution of the hydroxide. As barium is a group 2 hydroxide, and we know that group 2 hydroxide become more soluble when moving down in the group. So when solubility increases, the pH also increases. So the pH will be 13 for barium hydroxide, as it is below in group 2. The correct option is therefore B. Question 14. Silver nitrate aqueous is added to a solution of a halide ion X negative and aqueous ammonia is then added. The ionic equations for the two reactions that occur are shown. This is the first equilibrium reaction and this is the second equilibrium reaction. Which statement is correct? A. The position of equilibrium 1 lies to the left when X negative is iodide ion. When X negative is iodide, what happens that silver iodide is formed, AgI. So as AgI is insoluble in aqueous ammonia, so therefore AgI will be precipitated out of the solution in solid form and the reaction will move in the forward direction. So we can say that the equilibrium will lie to the right rather than left. So A is incorrect. B. Increasing the concentration of ammonia causes the position of equilibrium 1 to move to the left. When concentration of ammonia is increased, so we are actually increasing the amount of product in second equilibrium. So when product is increased, the concentration of Ag plus will reduce as it is converted into product. So when Ag plus concentration is reduced, what happens that the first reaction will move backward as Ag plus is the reactant. Because for an equilibrium reaction, if you decrease the amount of reactant, the reaction will move in the backward direction. So B is correct. C. Kc for equilibrium 2 is larger when X is Cl negative than when X is iodide. When X negative is Cl, then AgCl is formed, which is soluble in aqueous ammonia. So it will convert into ions Ag plus and Cl negative. But when X is iodide, so then silver iodide is formed, which is insoluble. So because of AgCl, what happens that the silver ion concentration will increase. As for equilibrium 2, Kc is equal to the concentration of product, which is silver ammonia, divided by the concentration of reactant, which is silver aqueous and ammonia. So as we can see that the value of Kc is inversely proportional to the concentration of Ag plus. So when Ag plus will increase, the value of Kc will decrease. So when X is Cl negative, then Kc for equilibrium 2 is smaller. So C is incorrect. Option D, equilibrium 2 is a redox reaction. In redox reaction, oxidation and reduction occurs. As we can see that the charges on the element has not changed. Silver is still Ag+, nitrogen is still -3 on the reactant end product, and hydrogen is +1. So there is no change in oxidation state, so D is incorrect. The answer is therefore B. Question number 15. Water and ammonia take part in a reaction that produces the ammonium ion. Which statement about this reaction is correct? A. The ammonia molecule and the ammonium ion do not have dipole moments. Let's draw the structure of both. We have ammonia, in which nitrogen is making 3 single covalent bonds with 3 hydrogen atoms, and the lone pair is also present. Bond angle is 107. While in ammonium molecule, we have 3 single bonded hydrogen atoms, 1 coordinate covalent bond of nitrogen with another hydrogen, and the charge is plus. In ammonium ion, there is tetrahedral arrangement and all the bonds are symmetric in nature. So when all the bonds are symmetric in nature, what happens that the total dipole moment becomes 0. So for ammonium it is 0, but in ammonia we can see that a lone pair is also present, so therefore there is non-symmetric distribution of bonds. So ammonia must have a dipole moment. So option A is incorrect. Option B, the bond angles changes from 109.5 in the ammonia to 107 in the ammonium ion. As in ammonia, the bond angle is 107 and in ammonium ion it is 109.5. So B is incorrect. C, the reaction is a redox reaction. Let's write the reaction of ammonia with water. We have NH3 with a lone pair, H2O. Ammonia gives its lone pair to H positive, so it becomes NH4 positive along with OH negative. Nitrogen is -3 in ammonia, again it is -3 in ammonium ion, so no change in oxidation state has taken place. Similarly, hydrogen is +1 on the reactant side and +1 on the product side. Oxygen is -2 on the reactant side, -2 on the product side, so therefore C is incorrect. Option D, the water is acting as an acid. As we know that lone pair donor is a base and lone pair acceptor is an acid. So as water is accepting lone pair from nitrogen atom, so therefore water is acting as an acid. Correct option is therefore D. Question 16. Due to similar ionic radii, the reactions of lithium and magnesium and their corresponding compounds are very similar. Which statement about the reactions of lithium or its compounds can be predicted from this statement? We can say that the reactions of lithium are similar to magnesium. So let's predict the reactions of lithium. A. Lithium burns very slowly in oxygen, as magnesium burns fast in oxygen, so therefore lithium also burns fast. So this is incorrect. B. Lithium carbonate decomposes on heating in a blue Bunsen burner flame, forming lithium oxide and carbon dioxide. As we know that magnesium carbonate decomposes on Bunsen burner flame to form magnesium oxide along with carbon dioxide. So same reaction will be for lithium. So B seems to be correct. C. Lithium nitrate decomposes on heating, forming lithium nitrite, LiNO2 and oxygen, as magnesium nitrate decomposes to form magnesium oxide nitrogen dioxide and oxygen gas. So therefore lithium should do the same. So C is incorrect. D. Lithium reacts very violently with cold water, producing hydrogen. The reaction of magnesium is very slow with cold water. So therefore lithium should behave the same. So D is incorrect. Correct option is therefore B. Question 17. Which statement about group 17 elements and their compounds is correct? A. Chlorine reacts with cold concentrated sodium hydroxide to form NaCl and NaClO3. As chlorine in cold alkali forms sodium chloride, sodium chlorate, and water. So therefore A is incorrect. B. HCl is more thermally stable than HBr because chlorine is less electronegative than bromine. As we know that going down in group 7 the electronegativity decreases, so therefore chlorine is more electronegative than bromine, and because of more electronegativity HCl bond is stronger than HBr, so B is incorrect. C. Iodide ions are oxidized to iodine by concentrated sulfuric acid. Now we know that concentrated sulfuric acid can oxidize bromide and iodide. It cannot oxidize fluoride and chloride ions. With iodide ion, sulfuric acid will form iodine along with sulfur dioxide and water molecule. The oxidation state of iodide has changed from -1 to 0, so therefore this is oxidation. So C seems to be correct. D. Silver iodide is soluble in dilute aqueous ammonia. Now silver iodide is soluble in concentrated ammonia, only silver chloride is soluble in dilute aqueous ammonia. So D is also incorrect. The correct option is therefore C. Question 18. Which substance when warmed with aqueous ammonium chloride would produce an alkaline gas? As ammonium chloride is ammonium salt, we know that when it reacts with strong alkali, it produces ammonia along with salt and water. Let's move towards the options. A is carboxylic acid. So acid does not react with ammonium chloride to produce ammonia, so A is incorrect. B is alcohol. Alcohol is also very weakly acidic, so it won't react with ammonium chloride to form ammonia. C is ester. Ester is neutral in nature. It also does not react with ammonium chloride. D is sodium ethoxide. Sodium ethoxide is a very strong base and it will react with ammonium chloride to give ammonia along with the salt and alcohol. So therefore answer is D. Question number 19. Compound X is the oxide of period 3 element. Compound X reacts with water to give an acidic solution. A solution is prepared by reacting 0.1 grams of compound X with an excess of water. The solution is neutralized by exactly 25 cm³ of 0.1 mole per decimeter cube sodium hydroxide solution. What could be the identity of compound X? The compounds given are aluminum oxide, magnesium oxide, phosphorus oxide, and sulfur trioxide. Now among these, aluminum oxide is insoluble in water. Magnesium oxide forms a basic solution because it is metal oxide. Phosphorus oxide and sulfur trioxide form acidic solution. So it could be either C or D. The molecular mass of phosphorus oxide is 284 and for sulfur trioxide is 80. For sodium hydroxide solution, we can find the number of moles by multiplying concentration with volume in decimeter cube. So it is 0.1 into 25 divided by 1000. So the number of moles of sodium hydroxide is equal to 0.0025 moles. Let's find the number of moles of phosphorus oxide and sulfur trioxide. The mass in grams is given 0.1 grams, so the number of moles will be 0.1 divided by 284 for P4O10. It is equal to 0.0003521 moles. Similarly, for sulfur trioxide, we can find the number of moles by dividing mass in grams, which is 0.1, by molecular mass, which is 80. So it is equal to 0.00125 moles. As we know that phosphorus oxide dissolves in water to form phosphoric acid. Similarly, sulfur trioxide dissolves in water to form sulfuric acid. The neutralization of each solution will be first with H3PO4. It reacts with sodium hydroxide to form sodium phosphate along with water. We can balance this equation by writing 3 with sodium hydroxide and 3 with H2O. According to balanced equation, 1 moles of H3PO4 requires 3 moles of sodium hydroxide for neutralization. So therefore 0.0025 moles of NaOH will neutralize X moles of H3PO4. By cross multiplying, the number of moles of H3PO4 will be equal to 0.000833 moles. As the given moles of phosphoric oxide were 0.003521, so as the values are not equal, so therefore neutralization will not occur properly. So C is incorrect. Let's find the same for D. We have sulfur trioxide which forms sulfuric acid. So the neutralization reaction will be H2SO4 plus sodium hydroxide. It will form sodium sulfate along with water. Upon balancing, we would have 2 moles of NaOH and 2 moles of H2O. Now the ratio between sulfuric acid and NaOH according to balanced equation is 1:2, and we have 0.0025 moles of NaOH. So the number of moles of sulfuric acid that will be neutralized would be X. So by cross multiplying, we can find the number of moles of sulfuric acid, which comes equal to 0.00125 moles. As we can see that the number of moles are same as the number of moles of sulfur trioxide given, so sulfur trioxide is the correct option. The answer to this question is therefore D. Question 20. The unsaturated hydrocarbon Oct-1357 Tetraene can display geometric isomerism. This is the compound. How many isomers exist? For geometric isomerism, there are two conditions. One is that there must be a double bond between two carbon atoms, And second is that the carbon atom making a double bond must have two different groups or elements attached. If same elements are attached, then it won't show geometric isomerism. So in the structure we can see that this carbon is making a double bond, but it has similar atoms attached, so this won't show geometric isomerism. Again, at the last we can see that this carbon is also making bond with the same atoms, so this won't be a part of geometric isomerism. So we have two double bonds present. There are three possibilities for this isomerism. Either both of these double bonds show cis isomerism, or one of the double bond shows cis and the other bond shows trans. So it could be cis isomerism or cis trans isomerism, or both the double bonds show trans isomerism. The structures would be like this. For cis we can draw this is when both are cis. This is when one is cis, as similar atoms are present on the same side, and one is trans. This is when both are trans. So we can write cis, cis, as same atoms are on the same side. We can write trans, cis, or the other way around we can say cis trans. For third one we can say trans trans. So therefore option B is correct. Question 21. What is the correct name for the compound shown? Let's count the number of carbon atoms. We have 1, 2, 3, 4, 5 carbon atoms in the long chain. We have 2 CH3 substituents and 1 OH as a substituent. We have 5 carbon atoms in the long chain. With second carbon we have OH group. On third carbon we have 2 methyl groups attached. Rest are the number of hydrogen atoms. The numbering will start from this carbon, as the substituents have less number. On third carbon we have 2 methyl groups. On second carbon we have alcohol, so we can write 3,3-dimethyl. The long chain is of 5 carbons, so for 5 carbon we will write pentane. And on second carbon we have alcohol group, so we will write 2-ol. The correct option is therefore C. Question 22. A polymer has the following repeat unit. It is made from 2 different monomers. This is the repeat unit of polymer. Which pair of monomers could be used to make this polymer? In A we have 2 carbon alkene with chlorine atom and 2 carbon ethene. We can make the polymer. Addition polymerization will occur and double bond is converted into single bonds. As we can see that the polymer formed is of 4 carbon atoms, while in the question the polymer is of 6 carbon atoms. And also there is a chlorine atom with second carbon and double bond between fourth and fifth carbon. So A is incorrect. B, again we have chloroethene and butadiene with 2 double bonds present in 4 carbon atoms. Because of addition polymerization, as double bond is present, so we can write the first monomer. We have chlorine atom on 1 carbon atom and hydrogen with the rest. Similarly, we have double bond between first 2 and double bond between third and fourth carbon. Upon addition polymerization, the pi bonds converts into sigma bond. Similarly, this pi bond is converting into sigma bond, and new bonds are formed on the sides. As this pi bond is made up of 2 electrons, so one of the electron is still remaining on this carbon atom, while from the breaking of this pi bond, 1 electron is left on this carbon. So these 2 electrons can make a pi bond between these 2 carbon atoms. Let's draw the structure of polymer that is formed. We have carbon, carbon, then chlorine atom present on the second carbon atom. Then we have 4 carbons. And a double bond is formed between these 2. Now chlorine is on second carbon, while double bond is present between fourth and fifth. So therefore this repeat unit is same as the one given in the question. So B could be the possible answer. In C we have chloroalkane as the first monomer and butene as the second one. As we can see that no double bond is present on the monomer, so therefore addition polymerization cannot occur. So C is also incorrect. Now moving towards D, in D we can see that the double bond is present between these 2 carbon atoms and also alkene is present. Let's draw the monomers. This is the first component and this is the second one. As double bonds are present, so therefore addition polymerization will occur and new bonds are formed on the sides. Pi bond is converted into sigma bond. The product will be like this. We have carbon-carbon single bond and 2 methyl groups are attached separately. Similarly, for these 2 carbons we again have single bond and chlorine is also present. Now this structure is totally different from the one given in the question, so therefore D is also incorrect. The correct option is therefore B. Question 23. Compound X contains 2 functional groups. This is compound X. We can see that we have ketone functional group and aldehyde functional group. Which reagent will react with only one of the functional groups? A. Acidified potassium dichromate 6. Now acidified potassium dichromate is an oxidizing agent and it will oxidize aldehyde to carboxylic acid functional group. So CHO will change into COOH, while ketone cannot be oxidized further. So A will react with only one of the functional groups. B is 2,4-DNPH. Now dinitrophenylhydrazine reacts with both aldehyde and ketone functional groups. So therefore B is incorrect. C is hydrogen cyanide, and hydrogen cyanide converts both aldehyde and ketone into hydroxynitriles. The product will be like this. This is for ketone and this is for aldehyde. So C is incorrect. In D we have sodium tetrahydridoborate This is a reducing agent and it can reduce both aldehyde and ketones. Aldehyde is converted into primary alcohol and ketone will be converted into secondary alcohol. The structure will be like this. Secondary alcohol for ketone and primary alcohol for aldehyde. So D is also incorrect. The only correct option is A. Question 24. Ethanol can be converted into ethene in a single reaction. Ethanol can be converted into bromoethane in a single reaction. Under standard laboratory conditions, is a catalyst used in these reactions? Now, ethanol can be converted into alkene by passing alcohol vapors over hot aluminum oxide as a catalyst. So therefore, catalyst is needed for this conversion, so it could be A or B. Now for second reaction, bromoethane can be formed from ethanol by nucleophilic substitution with phosphorus tribromide. The product formed is bromoethane along with H3PO3. No catalyst is required for this reaction. The correct option is therefore B. Question 25. Diols in which both hydroxy groups are bonded to same carbon atom can spontaneously eliminate a molecule of water to produce a carbonyl compound. Which compound after complete hydrolysis gives silver mirror with Tollens reagent? This statement shows that if carbon atom is bonded to two OH functional groups, so this carbon can eliminate water molecule and form carbonyl compound, which could be aldehyde or ketone. Tollens reagent gives positive result or silver mirror only with aldehydes. The functional group of aldehyde is RC double bond OH. Let's find the answer. A is 1,1-dibromobutane. So the structure is 4 carbon atoms for butane, and on first carbon we have 2 bromine atoms attached. Upon hydrolysis, nucleophilic substitution will occur with OH. So the product will be OH replaces Br. As both OH groups are attached with the same carbon, so therefore a water molecule can be eliminated according to the statement, and a carbonyl carbon is formed. Putting number of hydrogen atoms, we have 2, 2, 2, 3, 1, 2, 2, 3, 1, 2, 2, and 3. As this product is an aldehyde, so it will give a silver mirror test with Tollens reagent. So A could be correct option. B is 1,2-dibromobutane. So we have 1 bromine atom on first carbon and 1 bromine atom on second carbon. Upon hydrolysis, it will lead to the formation of diol, in which OH group is attached instead of bromine. As we can see that OH group is attached to 2 different carbon atoms, so therefore elimination of water molecule will not occur. So B is incorrect. For C, we have 1,3-dibromobutane. So bromine is attached with first and third carbon atom. Upon hydrolysis, OH will replace Br on first and third carbon. Again, carbon atom is not bonded to two OH functional groups, so therefore water molecule elimination will not occur. So C is also incorrect. D is 2,2-dibromobutane. So we have 4 carbon atoms in butane, and on second carbon we have 2 bromine atoms. Upon hydrolysis, it will form alcohol. OH groups replaces bromine atoms. And as we can see that OH groups are attached with the same carbon, so elimination of water molecule will occur. And a carbonyl carbon is formed. Putting the number of hydrogen atoms. The product formed is ketone. As ketones do not give silver mirror with tolerance reagent, so D is also incorrect. The only correct option is A. Question 26. Which alcohol will give a yellow precipitate when warmed with alkaline aqueous iodine? For alcohols, you should always remember that only that alcohol which is having CH3 group directly attached with the carbon atom having OH functional group will give positive result with alkaline aqueous iodine, and Triiodoform is formed, which is yellow precipitate. Let's move towards the options. We have A, 3 carbon atoms in the long chain. With second carbon atom we have 2 methyl groups attached, and with the last carbon we have OH functional group. Putting hydrogens. As we can see that OH is attached with this carbon, and there is no methyl group directly attached with this carbon, so A does not give positive iodoform test. B is alcohol having 2 carbon atoms in the long chain, and with second carbon atoms 3 methyl groups are present. Putting hydrogens. As we can see that OH group is attached to this carbon, which is directly attached to the methyl groups. But this is the example of tertiary alcohol, and tertiary alcohol does not oxidize. So therefore option B will not give positive result with alkaline aqueous iodine. In C we have 4 carbon atoms in the long chain, OH functional group with the second last, and also methyl group. Putting hydrogen atoms. Again we can see that OH is attached with this carbon, which is directly attached to 3 other carbon atoms. So this is also an example of tertiary alcohol, and tertiary alcohol does not oxidize further. So C is also incorrect. Moving towards D. We have 4 carbon atoms in the long chain, and OH group is attached with the second carbon. Putting hydrogens. As we can see that OH is attached to this carbon, which is directly attached with one of the methyl groups, and it is secondary alcohol, so it will oxidize to ketone. And ketone having methyl group directly attached with the carbonyl carbon gives positive result with alkaline aqueous iodine. So D could be correct option. So therefore answer is D. Question 27. How many structural isomers are there of molecular formula C5H10O that give a red precipitate with Phelan's solution? Now Phelan's solution gives positive result only with those compounds that have aldehyde functional group present. Let's draw possible structures of C5H10O that are aldehydes. So we have 5 carbon atoms in the long chain. We can also have 4 carbon atoms in the long chain. And 1 carbon is acting as a substituent. We can change the position of substituent in 4 carbon long chain. It could be on this carbon too. Another possible aldehyde is having 3 carbon atoms in the long chain and 2 methyl groups attached with the second carbon atom, putting missing hydrogens. The molecular formula of all these 4 compounds is C5H10O. The names of these compounds are, the first one is having 5 carbon atoms in the long chain, so it is pentanol. Second one is having 4 carbon atoms in the long chain and methyl group is attached with the third one, so it is 3-methyl butanol. In the third structure, we have methyl group attached with the second carbon atom, so it is 2-methyl butanol. In the fourth one, we have 2 methyl groups attached with the second carbon, so it is 2,2-dimethyl propanol. So 4 structural isomers are formed that give positive result. The answer is therefore D. Question 28. Which statement about the use of alkane fuels in internal combustion engines is correct? A. C8H18 is used as fuel in internal combustion engines and reacts with oxygen and nitrogen from the air. Now C8H18, if in straight chain, is octane, and octane is a liquid that can be used as a fuel. It does react with oxygen but does not react with nitrogen in the internal combustion engines. So therefore A is incorrect. B. In limited oxygen, carbon monoxide is produced. When less oxygen is present, CO is produced instead of CO2, which oxidizes SO2 to SO3 in the atmosphere. Now, carbon monoxide is not an oxidizing agent, it is actually a reducing agent. So therefore, B is incorrect. C. The catalytic converter removes polluting gases including NO2 and CO2. Now, NO2 is acidic gas and it is polluting in nature and it is converted into nitrogen in catalytic converters, and CO2 is not a polluting gas and it is not removed by catalytic converter, so C is incorrect. D. Unburnt hydrocarbons and NO2 can react in sunlight to produce photochemical smog. Now NO2 is acidic gas and it can react with unburnt hydrocarbons in the presence of sunlight. A photochemical smog is also produced, so D is correct option. The answer is therefore D. Question 29. Compound Z is shown. We can see this is compound Z. What is produced in good yield when compound Z is treated with excess of sodium carbonate solution at room temperature? Let's look into the structure of compound Z. We have carboxylic acid functional group, alcohol functional groups, ester functional group, and alkene functional group present. Among these functional groups, only sodium carbonate reacts with carboxylic acid functional group to form the product. Now the product will be sodium salt of carboxylic acid along with production of carbon dioxide and water. Alkene, ester and alcohol, they will not react with sodium carbonate. Among the given options, we can see that in A, sodium salt of carboxylic acid is formed and the other compound has not changed. In B, the alcohol has also reacted, which is incorrect. In C, again the alcohol has also reacted, which is incorrect. In D, we can see that the ester is broken down, which is also incorrect. The only correct option is A. Question 30. The infrared spectrum shown was obtained from compound G. What could be compound G? We can see that this peak is significant and it comes exactly between 1700 and 1800, so the value could be 1750 per centimeter. And this is also a sharp peak. A is this compound having alcohol functional group and also ketone functional group. Ketone gives between 1670 to 1740 sharp peak, while alcohol gives a sharp peak between 3200 to 3600. As we can see that the sharp peak between 32 and 3600 is absent, so therefore A is incorrect. In B, we have carboxylic acid functional group having 3 carbon atoms. We have carbonyl of carboxylic acid and also OH bond. This carbonyl will give between 1680 and 1730 sharp peak, while this OH will give a peak between 2500 to 3000, and the peak must be sharp and very broad. As this OH peak is absent, so B is also incorrect. In C, we have carbonyl carbon present in ester, and this shows a peak between 1710 to 1750 per centimeter, and the peak should be sharp. No other sharp peak is found. As in the structure, we can see that the only sharp peak is at 1750, so therefore C could be correct option. For D, we have alkene functional group, and alkene shows a peak between 1500 to 1680 per centimeter, and the peak should be weak. As there is no such peak present, so therefore D is also incorrect. The answer is therefore C. Question 31. The symbol for phosphorus ion is P -33315. The symbol of potassium ion is also given. What do these two ions have in common? Number 1, the same number of electrons, then we have neutrons, then protons. Let's find electrons. In phosphorus, we have 15 electrons already present and the negative charge is 3. So 3 electrons are added, so total number of electrons will be 18. In potassium, we can see that we had 19 protons, so there were 19 electrons and 1 electron is lost as the charge is positive. So number of electrons left is also 18. So 1 is correct. 2 is the number of neutrons. Now number of neutrons can be formed by subtracting mass number with atomic number. So we have 18 neutrons for phosphorus. Similarly, we have 18 neutrons for potassium. So 2 is also correct. 3 is the number of protons. As in phosphorus we have 15 protons and in potassium we have 19 protons. So 3 is wrong. As both 1 and 2 are correct, so therefore answer is B. Question 32. The repeat unit of a polymer is shown. Which types of intermolecular forces exist in the solid polymer? We can see that in the repeat unit we have carbon-nitrogen bond present. We also have ester functional group present, which consists of carbon bonded with oxygen. Number 1, we have temporary dipole-induced dipole interactions. Now temporary dipole and induced dipole are made by non-polar molecules. So we can see in this chain we have CH2 which is non-polar. We have C2H5 which is non-polar. So therefore they will be making temporary dipole induced dipole interactions with other molecules. So option 1 is correct. Option 2, permanent dipole interactions. Now permanent dipole are made by polar molecules. Nitrogen is more electronegative than carbon, so therefore the partial charges will develop. Similarly, oxygen is more electronegative than carbon. So due to the presence of these polar components in the polymer, permanent dipole interactions will also be present. Third is hydrogen bonds. Now for hydrogen bonding, fluorine, oxygen or nitrogen must be present, and there should also be a hydrogen atom directly bonded with either of these three elements. As we can see that in the repeat unit there is no such thing as hydrogen bonded with fluorine, oxygen or nitrogen, so therefore hydrogen bonds will be absent. Option 1 and 2 are correct, so therefore answer is B. Question 33. The diagram illustrates the enthalpy changes of a set of reactions. Which statements are correct? Number 1. The enthalpy change for the transformation U to R is plus 42 kilojoules per mole. They have given the transformations from R to S and S to U. Similarly, the transformation is given from R to T and T to U. R to T is absent, so we can find this one. As the product formed is same from both sides, so therefore the energy change will also be same. So we can say that R to S and S to U, the energy will be equal to R to T and T to U. From R to S we have negative 134 kilojoules per mole. From S to U we have plus 92 kilojoules per mole. While from R to T the energy is not given, while T to U is negative 75 kilojoules per mole. So we can find the value of X. It comes equal to 33 kilojoules per mole. So we can write 33 with R to T. Now from R to T we have 33 kilojoules per mole, while T to U is negative 75 kilojoules per mole. Now in the question they have asked about the energy transformation from U to R, so it will be reverse. When going in reverse the energy change will change the sign, so it will be plus 75 from U to T and negative 33 from T to R. So combining these two we can get plus 42 kilojoules per mole. Therefore option 1 is correct. Option 2. The enthalpy change for the transformation T to S is endothermic. The energy change from T to U is given. It is negative 75. While from U to S it will be the reverse of plus 92. It will be negative 92. So in total from T to S the energy change will be, we have to add these two. So it will be minus 167 kilojoules per mole. So the energy change is exothermic because the sign is negative. So option 2 is incorrect. Option 3. The enthalpy change for the transformation R to T is negative 33 kilojoules per mole. As from R to T we have calculated the value and it is positive 33, so therefore option 3 is also incorrect. As only option 1 is correct, so therefore answer is D. Question 34. Which statements about a reaction that has reached dynamic equilibrium are correct? Let's suppose we have a chemical reaction. A and B react together to form C and D. Now when equilibrium is reached, still A and B will react together and move in the forward direction, while C and D will react and move in the backward direction. Let's move towards the options. Number 1. The rate of forward reaction equals the rate of reverse reaction. Now at dynamic equilibrium, what happens that the rate of forward is equal to the rate of reverse reaction. The reaction does not stop. So option 1 is correct. 2. There is no overall change in the concentration of reactants and products. At equilibrium, the reactants and product concentration become constant, as continuously product is changing into reactant and reactant is changing into product at the same rate. So option 2 is also correct. 3. There is no change in the measurable properties of the system. Now by measurable properties we means that the ratio of partial pressure if the reactants and products are gases, or it could be the concentration of reactants and products. As we know that the ratio of partial pressure, if these are gases or the concentration becomes constant, it is not changing in equilibrium, so therefore option 3 is also correct. All 3 options are correct, so the answer is A. Question 35. Group 2 elements and their compounds show trend in their physical and chemical properties. Barium is above radium in group 2 of the periodic table. Which statement are likely to be correct? Option 1. Barium hydroxide is less soluble than radium hydroxide. Now for group 2 hydroxide, the solubility increases down the group. As barium is above radium, so the solubility of barium hydroxide would be less than radium hydroxide. Option 1 is correct. 2. Barium reacts less vigorously with water than radium does. Now the reactivity of group 2 metals also increases down the group. This is because electrons are easy to lose as the size of atom increases. So therefore radium is more reactive than barium. So option 2 is also correct. 3. Barium sulfate is more soluble than radium sulfate. Now the solubility of sulfates of group 2 decrease down the group. This is because more stronger forces of attraction are present. So therefore barium sulfate will be more soluble than radium sulfate. So option 3 is also correct. As all options are correct, so therefore answer is A. Question 36. Which statements are correct? Number 1. The empirical formula of silicon 4 oxide is SiO2. This is correct because SiO2 is a giant molecular structure. So the empirical formula is that with one silicon 2 oxygen atoms are bonded. Option 2. The molecular formula of phosphorus 5 oxide is P2O5. This is incorrect because P2O5 is the empirical formula of phosphorus 5 oxide. The molecular formula is P4O10. Option 3. Silicon 4 oxide and phosphorus 5 oxide are both simple molecular compounds. This is true for phosphorus 5 oxide, but silicon 4 oxide is a giant molecular structure. So 3 is incorrect. as option 1 is only correct, so therefore answer is D. Question 37. Which reagents could be used under suitable conditions to oxidize alcohol to aldehyde? Number 1. Acidified potassium manganate 7. This is a strong oxidizing agent, so it can be used to oxidize primary alcohol such as propanol to 3-carbon aldehyde, which is called propanol. Number 2. Acidified potassium dichromate 6. This is also a strong oxidizing agent, so this will also convert propanol to propanol. 3 is Tollens reagent. This is a very mild oxidizing agent, so it can only oxidize aldehyde. It cannot oxidize alcohol to aldehyde. So 3 is incorrect, as only option 1 and 2 are correct, so therefore answer is B. Question 38. Which free radicals can be generated during a free radical substitution reaction between chlorine and ethane? Number 1. Methyl radical. Now methyl radical can be formed if reactant is CH4 with chlorine in the presence of sunlight, but as we have ethane C2H6, so therefore this is not possible to make 2 methyl radicals out of this one. So option 1 is incorrect. Option 2, CH2Cl CH2 radical. This product is possible if we have ethane, 6 hydrogens. This can react with chlorine radical to form radical on carbon along with the removal of HCl. Same can also happen with this carbon hydrogen bond. The radical formed can react with chlorine molecule to form chloride product. Again, this can react with chlorine radical to remove this hydrogen atom in the form of HCl. So the product will be CH2 CH2Cl. So this product is same as given in option 2, so 2 is correct. Option 3, we have CH3CCl2. So now this product can also react with chlorine radical to form CH3 CCl H radical with the removal of HCl molecule. Now again it can react with chlorine to form product having 2 chlorine atoms. Again it can form radical with the help of chlorine radical. So we have CH3 CCl2 along with the radical formed on carbon atom, and HCl molecule is removed. As this is similar to the product given in 3, so 3 is also possible, as option 2 and 3 are correct, so therefore answer is C. Question 39. Which substances have molecular formula C4H8O? Let's find the number of carbon atoms. We have 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons for this one. 1, 2, 3, 4 carbons for this compound. Now finding the number of hydrogens, there are 3 hydrogens attached with the corner carbon, 2 with this one, and 3 with the corner carbon. So in total we have 8 hydrogen atoms and 1 oxygen is also present. For 2, again we have 3 hydrogen atoms present with the corner carbons, One hydrogen with the central one, as it is making 3 bonds, so one should be with hydrogen. Similarly, this carbon is also making 3 bonds, so there should be one hydrogen atom. So in total we have 8 hydrogens and one oxygen is also present. In third option, we can see that this carbon is making double bonds, so 2 hydrogen atoms will also be bonded. This is making 3 bonds, so there will be 1 hydrogen, 2 hydrogens with this one, 2 with this one, 1 hydrogen is this. So in total we have 8 hydrogen atoms and also 1 oxygen is also present. So all 3 options are correct. So the answer is A. Question 40. Which reactions produce pentanoic acid? Number 1, we can see that in this reaction OH group is present on the second carbon, so this is secondary alcohol, and H plus and MnO4 negative is acting as a oxidizing agent. We can write the reaction. As this is secondary alcohol and we have OH group on second carbon, so this will be oxidized to ketone. The product will be CH3, CH2, CH2, carbonyl carbon on this, and CH3. The numbering will start from this carbon and the product is pentane 2-one. So option 1 is incorrect. Option 2, we have ester functional group and acid hydrolysis is taking place. Let's draw the structure of second one. We have carbon, oxygen, then carbon double bonded with oxygen, then we have 3 CH2 and 1 CH3. Upon acid hydrolysis with HCl aqueous, what happens that the bond between oxygen and carbon will break and carboxylic acid along with alcohol will be formed. The product would be CH3OH, alcohol, methanol, along with this carboxylic acid. As we have 5 carbon atoms present in this carboxylic acid, so the name is pentanoic acid. So option 2 is correct. In option 3 we have nitrile compound which reacts with sulfuric acid aqueous, so acid hydrolysis will occur of nitrile. So it is also converted into carboxylic acid along with ammonium salt. The reaction can be shown like this. We have CH3, then 3 times we have CH2, then carbon triple bonded with nitrogen. Upon acid hydrolysis, in the presence of sulfuric acid, what will happen that carbon nitrogen bond is broken and carboxylic acid is formed. Nitrogen will form ammonium salt with sulfate. As we have 5 carbon carboxylic acid, so it is pentanoic acid. So option 3 is also correct. So therefore answer is C.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.